The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Following questions using the second order reaction given below. So the rate constant is equal to 5.6 times 10 to the power of 2. And again, let's take a look at the units for rate constant. Remember, we said in the earlier slide that if you haven't seen the lecture, go back and watch it. It's the one preceding this one on rate law and whatnot. And we talk about where the units for the rate constant come from. Again, the units for the rate constant depend on the order of the overall reaction. And we'll go into more detail in that lecture. Okay, getting back to our two questions here. What is the concentration after 5 minutes if the initial concentration is 0.075 molarity? What is the half-life if the initial concentration is 0.075 molarity and if the initial concentration is 0.050 molarity? Okay, what we're actually going to do here is we'll go on to the next slide because we're a little bit limited for room, and we'll answer our first question there. All right. Well, what is the concentration after 5 minutes if the initial concentration is 0.075 molarity? Let's start here just by writing down our integrated rate law, and we know that our integrated rate law is the following. Right here, okay. Great. And now our question, right? It's asking us, what is the concentration after 5 minutes? So it's a concentration after some time, which is just this term here, right? And we have the initial concentration, we have the time, we also have our rate constant here. So let's just go ahead and fill in our values initially. And this is going to be 0.075. Right, plus our rate constant and our time of 5 minutes. Let's just put our conversion factor in now because we're going to need seconds. Right, over 1 minute. Wonderful. Okay. What you can do is, I'll let you do the math on that one. Just go ahead and equate all of this. Once you equate all that, then you just isolate for the concentration. And once you isolate for the concentration, right, your answer should come out to be 6.0 times 10 to the power of negative 6. And that there is the molarity. So great. Then the answer is telling us that the concentration after 5 minutes is going to be 6.0 times 10 to the power of negative 6. Okay, great. Let's actually move now to our next slide and do the next example. Okay. Example, second order reaction continued. What is the half-life if the initial concentration is 0.075 and if the initial concentration were 0.05 molarity? Okay, so let's do both, and this is a good example just to kind of help you become familiar with the equations. And our equation again for half-life was the following. Great. This is going to come here, and if we recall, the value for our rate constant was 5.6 times 10 to the power of 2 with the following units, and our concentration that's telling us that it is, the initial one here is 0.075. This is going to give us a half-life value here of 2.4 times 10 to the power times 10 to the power of 2. Now let's see what our half-life would be if we did an initial concentration that was 2.